My presentation is about the relationship between heat conduction and economic equilibrium from an econophysical perspective. It will be in four parts. Firstly, I will start by an introduction. Then I'm going to talk about the law of supply and demand. After that, I will adapt the context of thermal conduction to the economic equilibrium. Finally, I will finish by a conclusion. People are frequently surprised to learn that physicists are applying their subject to finance and economics, but history teaches us otherwise. Aristotle, for example, presented the foundation of physics in his Physica by suggesting that nature is composed of things that change and that studying these changes is useful. On the other hand, he mentioned that the barter is a form of exchange which is used in most societies. In 1900, the mathematician and theoretical physicist Louis Bachelier developed a theory of stock prices based on ideas of Brownian motion and random walks. The concept of the thermoeconomics was introduced by the physicist François Rodier in 2015 in his paper The Thermodynamics of Economic Transitions. It describes economic exchanges by assigning to each production two potentials similar to Gibbs-Duham's potentials, which is pressure and temperature. Taking account the assignment of the thermal temperature to the notion of price, we suggest in this contribution a reflection on one of the important aspects of the use of thermodynamics in understanding the mechanism of the law of supply and demand. We will approach it from the particularity of the conduction thermal transfer mode, in particular the Fourier law, very famous in thermodynamics for the various applications associated with it. I will first introduce the notion of supply and demand equilibrium. The supply curve is the relationship between the price of certain good and the amount of that good producer makes. Supply curves typically slope upward since a higher price means producer can earn more from each product they sell, so it is worth it for them to produce more of that product. The demand curve is the relationship between the price of a certain good and the amount of that goods buyer want to buy. Most demand curves slope downward. Intuitively, we'll buy more of something if it is cheaper. If we graph supply and demand curve, we get the price of equilibrium. So producers produce exactly the products that the buyer wants to buy. The experience proves that during a heat exchange between two solid 1 and 2 with different temperature, their temperatures converge toward an equilibrium temperature. Based on the standard notions of thermodynamics, we believe that in economic language it is possible to propose the following interpretation. On a market of pure and perfect competition, in a situation of imbalance, in order to reach the price equilibrium, the quantity required must be reduced, a hot body loses heat, as the quantity offered must be increased, cold body receive heat in order to reach the price level that balances the quantity offered and the quantity demanded. Then the market situation can be described by the equation Qs equal to Qd. Qs is the quantity of supply, Qd is the quantity of demand. Experience in thermodynamics shows that solids do not conduct thermal energy in the same way. In an economic context, where supply and demand intersect to reach an equilibrium price, we can define an economic conductivity. This line measures the purchasing power of consumers in this market. I conclude my presentation with the table that contains the different physical notions discussed during my talk and its corresponding concepts in economy.